Everybody have their count? All right, I'm going to go around the room and ask you for what your number was. And then we're going to take that data and analyze it. Parker, how many did you get? 12. Jimmy? You said 7? Savannah? 10. Jenna, sorry, my brain just froze for a moment. 12. Cassandra? 13. Emma? 13. Xavion? You said 18? Israel? 15. 15. Grayson? You said 16? Max? 15? Joan? 15. Donnell? 10. Allison? 18. And Justin? 18. All right, I did this yesterday just to see what I could do. I came up with 19. All right, copy that list into your notes. There are 15 people in the room plus me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 plus me. So we have a grand total of how many pieces of data? What is our n value here? N is 16. Is this categorical or quantitative data? Do you need another packet? This is quantitative data. So whenever we have quantitative data, we're going to be doing means. Good question. Categorical data means proportions. So quantitative data, we're going to use means. Categorical data, we will use proportions. I left my S behind there. There we go. So hopefully you guys have that list written down. We're going to use your calculator. We know our n value. We said that's 16. We're going to find x bar and the standard error SX. So grab your calculators for me. We want to go into the list. So stat, edit. I'm going to pull mine up on the screen so that I can do it too. Except I'm going to need a list of numbers to work from. Okay. So I've got my TI calculator up here. So stat, edit, which is option number 1. If you have something in that list, you guys remember how to clear that out? Arrow up to the top, hit clear and enter, and it'll wipe the entire list. All right, so let's enter that data into here. Remember to hit enter after each piece. So 12, 7, 10, 12, 13, 13, 18, 15, 15, 16, 15, 15, 10, 18, 18, and 19. Does anybody remember how to get our statistics, our X bar, which would be the mean of our sample, or the SX, the standard deviation of our sample, or our sample error. Anybody remember how to do that part? Okay, so we're going to hit stat again. We're going to arrow over to calc. And we want one variable statistics because we just had a sample from one group. So I'm going to hit enter. Mine gives me options here. There we go. Tells me my n value right here, which we already knew. There's my X bar, 14.125. Here's my sample standard deviation, 3.38. Take a picture of that again so that I can write that down. All right. Does anybody need help getting their statistics on their calculators? All right. I gotta remember where it is on yours.
These are
just list these. Yep, put those in your list. All right. So 14.125, 3.38. We want to construct a 95% confidence interval to estimate the mean number of states, not a senior, an AP Stats student. Can name. We are using you guys as a random sample of all AP Statistics students for the purposes of our confidence interval building. All right. So coming down here, we have to walk through our four-step process. Anytime we are asked to construct a confidence interval, or anytime we are asked to do a significance test. So is there convincing evidence would mean four-step process. Confidence intervals would mean four-step process. So in the state for a confidence interval, we have to name our parameter, we have to define it and name it, and we have to name our confidence level. Are we working with categorical or quantitative data? Quantitative data. So we said quantitative data, we're going to be using means, right? So what is the parameter for a mean? Mu. Mu is the parameter for a mean. And then we need to define what that means in this situation. Mu would mean what? The true mean number of states that an AP student can name in 1 minute. The true mean number of states an AP Stats student can name in 1 minute. What confidence level are we going to be using? 95%. When we did the plan stage for proportions, the name of our procedure was a one sample z-test for P. How many samples did we take today? 1. So this would be a one sample. Do we use z when we're talking about means? We use t. So a one sample t interval for, what is our parameter here? For mu. One sample t interval for mu. Just like with proportions, just like with significance testing, we have to check our conditions. What are those 3 conditions? Random, 10%, and normal. So random, 10%, normal. Randomness. We're going to go with assumed randomness, that you guys are a random sample of all AP Stats students. Why do we need a random sample or a random assignment? So that we can generalize to our whole population, yes. 10%. What was our sample size? 16. 16 is less than or equal to 1/10 of what? All AP Stats students. Have we met that condition? Definitely. We do that so that we can sample without replacement, so that we have independence. There are at least 160 AP Stats students. Normal. Why do we need to check for normality? Yeah, we need to know that our sampling distribution is approximately normal here. How do we check for normality with means? We talked about 3 different ways that I could do this. Aiden. Central limit theorem. Yep.
Law of large counts, angle draw.
There was one more way. So law of large counts would be for my proportions. So that's true, but for P. If I know what about my whole population? If it tells me at the beginning that my whole population is approximately normally distributed, I get this one for free. Do we know that the number of states an AP Stats student can name is approximately normally distributed? We don't get that one. Can we use central limit theorem? Why not? We only have 16 people here today. We are less than 30, so we can't use central limit theorem. So we're going to have to sketch this. Grab your calculators. I'm going to show you how you can use your calculator to get a very quick sketch, because all we're looking for is that it does not have a strong skew. It doesn't mean it can't be skewed at all. It means it does not have a strong skew, and it does not have these huge outliers. So grabbing your calculator, all your data should still be in list 1, correct? All right. So you're going to hit second and y equals. That takes you to the stat plot. You need to make sure that this is turned on. So I'm going to enter into number 1. On should be dark. If it's not, hit enter there so that it says on. And then we're going to go down to type. We want to make a histogram, so you want the one that looks like a bar graph. You're going to arrow over, make sure that that's there. Your X list should be coming from L1. Frequency, just 1. Make sure that yours looks like this. And then we're going to hit where it says zoom right here. Option number 9 says zoom stat. This will make sure that that window is sized perfectly for the statistical data that you have entered. So we're going to go with option number 9 where it says zoom stat. And there's our histogram. So we can sketch a real quick graph of that. Do we have a strong skew here? Any outliers? Nope. Just looking from that picture, does it look like it is approximately normally distributed? Cool. Then we've got our normality condition met. Sketch this guy next to where it says normal. Yes, sir.
I tried it with L2 and there's no L1.
Oh, you don't have an L1. Okay, so when we go to stat plot, we're just going to set this to L2. So second and number 2 gets you L2. And then we'll hit zoom and stat plot. There you go. You're welcome. Do you guys need me to leave this up on the screen anymore? Okay. I'm going to bring mine back up so that I can get this sketched in. And we do need to label what this is meaning. All right, so I'm going to get this here. What is this a histogram of? Where did our data come from? Yes. This would be states named in 1 minute, or very specifically number of states named in 1 minute. You have to label your histogram. If all you have is a picture and you're not saying what it's of, it's kind of meaningless. Have we met all of our conditions? Cool. That means we're ready for do. If the conditions are met, perform the calculations. What's the general formula for any confidence interval?
Standardized test statistic equals state minus parameter over
For significance testing, yes. We want to do for an interval. Point estimate plus or minus. Critical value times. Yeah, so technically, like just the very, very general is point estimate plus or minus our margin of error. Specific formula for this confidence interval. What is the point estimate when we're doing means? X bar. So X bar plus or minus T star. SX over square root of n. Yes. So let's substitute our numbers in. What was our X bar? 14.125. Plus or minus T star. How many degrees of freedom do we have? 15. This is n minus 1. So 16 minus 1. We have 15 degrees of freedom. You're going to need to grab your table B. Try to locate mine. There we go. 15 degrees of freedom. And we want a what percent confidence interval? 95. You said 2.131. We're going to multiply that by Sx over the square root of n. What is Sx? 3.38 over square root of 16. Hey, that came out to be a nice pretty number this time. Normally it's not. So let's pop that in the calculator. 2.131 times 3.38 over the square root of 16 or over 4. Since our point estimate, our x bar went out to 3 decimal places, let's take this out to 3 decimal places. Ballpark, what did we get? 1.801 when we round it. So now we're ready to make our interval. What is our confidence interval? 12.324 on the lower end, 15.926 on the upper end. Get that all up here on the screen over here. How would we interpret this interval in the context of our problem? We are 95% confident. Oops. That what?
The interval from 12.324 to 15.926 captures the cumulative number of states that AP Stats student can name.
Yes. We are 95% confident that the interval from 12.324 to 15.926. Normally I would stick in context here. 12.324 to 15.926. What kind of units would I stick on there? States. Captures the true mean, because that's what we were trying to find. That's what we were trying to find an interval for.
Teachers, pardon this interruption. A few announcements before releasing to the convo. If you did not receive the seating chart from Mr. Seacos, please understand that you cannot attend the convo in person. 2 emails were sent earlier. One yesterday from Mr. Wilkerson and one this morning from Mr. Seacos regarding how to access the live stream. Again, if you did not receive a seating chart from Mr. Seacos, you cannot attend in person. There is no room. Teachers, we ask that you stay near your students in the section that you are assigned. It is a tight space, so please make sure you are in the proper rows in those sections. At this time, balcony section seating only. Please report to the auditorium. Balcony seating only. Everyone else, please stay in your classrooms until you hear an announcement. Do not leave early. We need to get there quickly and get seated. Again, teachers, make sure that you get your students to your section and actively supervise them. We appreciate all your help. Announcements will be made momentarily for the rest of the sections. Thank you.
All right, so technically speaking, we still have time in class. Mr. Seidella cut in like with almost 10 minutes left to class. So we are going to go ahead and flip this over on the back, get our important ideas down, and see if we can get through some of that check your understanding. Because I'm trying to make sure, since this is such a short unit, we don't have a lot of wiggle room. I want to get through as much as we can today so that we don't fall behind. All right. All right, so 4-step process. This is exactly the same type of process that we did when we were doing confidence intervals for parameters. We need to state our parameter, so we need to define it, and we need to state what confidence level we're using. Name of the test here would be a 1-sample t interval for mu. Conditions, random and 10% are exactly the same as what we've done before. For normality, there's 3 ways that we can get that. They either tell us that we already know the population is normally distributed, sample size is bigger than 30, so we can use our central limit theorem, or we got to sketch out our sampling distribution. And you can use your calculators to make a histogram. For the do, this is the formulas, the work, and our answers. So point estimate plus or minus margin of error. X bar plus or minus T star times Sx over square root of n, with degrees of freedom being n minus 1. Remember, for proportions, we use a z. So we have a z star critical value. Here we use a T star critical value, so we have to know our degrees of freedom. And then our conclusion, we are blank % confident, blah, 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 blah. If you're done copying this down and you want to get started on the check your understanding, start on part B. I want to go through part A together. If you are not done copying this down, snap a picture of it, because I do want to go through as much of the check your understanding as we can before the convocation.
Seating at the front floor of the auditorium, front sections of the auditorium, seating at the front floor of the auditorium, front seating sections at this time, front seating sections at this time.
All right. So in part A, it says how many households need to be surveyed to estimate mu at a 95% confidence level with a margin of error of at most 3 pounds. We did this, if you pull out your packet from 2 chapters ago, from chapter 8, we did this with our proportions. So I'm looking at, let's see, I want my margin of error, that would be this part back here, T star times Sx over square root of n. If I know that I want that margin of error to be at most 3 pounds, then it needs to be 3 equals. Like I don't want it to go over that. Any idea? We're getting interrupted left and right. Any idea what T star we should use? Can we figure out our degrees of freedom? No. Here we go, estimated standard deviation of 36 pounds, but we're trying to figure out how many households we should survey. So we're trying to find n. Don't I need to know n to figure out my T star, my degrees of freedom? If I don't know what T star to use, and in this case I don't because I don't know what n is, we're going to use our Z star, which is down in that very last row where it's the infinite degrees of freedom. Yes. So we're going to use 1.96. We have the standard deviation from right here, but we don't have n. So now that we've got all those pieces filled in, I want you guys to calculate n for me. Anybody have a ballpark for this one? We 553, was it exactly 553? 0.19 something something something. So whenever we have a decimal, we're always going to round up. So 553.1904, we're going to round that up, use 554.
Remainder of floor seating at this time. Again, remaining teachers, please get the kids to the auditorium and be with them. Those teachers in classrooms viewing the convo via streaming, no passes out. There should not be any students out in the hallways during the convo. Again, no passes out of the classrooms during the convo. Do not release to fourth period until you hear an official announcement. Do not release to fourth period until you hear an official announcement. Ignore the bell for fourth period. Ignore the bell for fourth period. There will be an official announcement to move to fourth. Again, all students should remain in classrooms if you are not at the convo. No passes out. Thank you.
We are only as smart as the dumbest person, so he's going to say it over and over and over. For part B, how many households did they actually sample? 15 households. So what should we do with that data there? Yeah, we're going to find our sample mean. We're going to find x bar. Sample standard deviation, Sx. Go ahead and pop that into your calculator and do that for me. When we're doing a confidence interval, what do we have to include in the state portion? Parameter and confidence level. What is the parameter that we are working with? Mu. And what would mu mean here?
True trash for households and large scale.
Yep. True mean weight of all trash for households in this community, right there. And what confidence level should we use? 95%. What are the things that we need in the plan stage? Name of our procedure and check our conditions. What is the name of the procedure in this case? One sample t interval for mu. Conditions. What are our three conditions? Random, 10%. Do we have random? Yep, it says random sample of 15. 10%. Do we have 10%?
Yeah.
It would mean there'd at least have to be how many households? 150. We do that so that we can sample without replacement, so that we have independence. Last thing we need to check is what? Normality. Did they tell us that the population was normally distributed? No. Can we use central limit theorem? Then we've got to make a sketch. Do you guys remember how to make it do a sketch? My sketch kind of looked like this. It looked like these stair steps. Does it show a strong skew? Do we have a strong skew to it? No. The graph yesterday, if you look back at yesterday's lesson, that graph showed a strong skew. It was really high, and then it drug out to the side. This one does not show a strong skew, doesn't show any big outliers. We'll finish this up tomorrow. While the convocation is going on, I am going to pass back your tests from Tuesday so you guys can see that. Max, I'll get you started on yours.